everyone, welcome to Try Right, the new era of learning, which is Fact 365. Today we're discussing about breakfast search algorithm in AI Part D. In that we have in that we discuss about example sum of explanation, okay, of BFS. In the given displaying graph, we have nodes like A, B, C, D, E, F, G, H, I, right? Displaying in the graph, okay? So, it starts with FIFO. We have front and FIFO queue, right? So from the starting and queue, right, we have start from A, right? So we have start from A. A is selected as the starting node and it is added to the queue, right? Uh, Consequently, it has font. Is A. Font is A now, okay? So it visited A, right? It will not totally it visits A. The algorithm visits neighbors of A. What are the neighbors of A we have? We have B is identified, B and I, right? We have B and I. So the node B is identified as a neighbor and it is highlighted. So next step, you cross the line, ensure neighbor, like we have visited neighbor A, right? So A, B and I or the discovered has neighbor of A, okay? B is added to the queue. Now B is added to the queues, right? So and I or discovered has neighbor of A, right? The font of the queues becomes B and the queue is show as B, right? It is staged B. Now here another sequence DQ node B is DQ'd from the font. The prompt change the DQ next vectors, right? Visit the neighbor B. The algorithm now visits, and we have another request I. So it directly visits I. So now we have visited I, right? The algorithm visits the neighbor I. It visiting. It's completely visited. Right? Now it enter in font, it enters the I. It added I. So it visits the neighbor of I is. The neighbor of I we have E and F, right? It identifies E as the nearest highlighted neighbor and in NQs that have E is added to the queue. This queue becomes FE, right? The queue has an FE now, right now. So when it the next for the next it takes visiting process like it has we use the queue as E, right? So E is added in the queue, right? It visits next B of E and it directly forms IF, right? So it directly comes from EI, it backs to the A and it comes to the begin neighbor of B, right? It comes to the neighbor of B. Now we added the sequence F, right? We have only neighbor of B is F, right? So we added the neighbor into the F. So from the content of F, we have F neighbors has we have E and G. So if we added the Q G, right? The visit neighbor of B. We have visited neighbor of B, and we want to add the we already discovered because we already B is discovered, right? So finish it with B, and we comes to the F right now, and we DQ next vertex, right? F and G. We consider any of visit of I, right? We can visit I, and after that we have visited the neighbor of I again. So then already discovered it already visited visit neighbor of I again. So in that we found out E. Then we discovered E, right? For F nearest content. Then we have to move the queue into next discovered of E. We already visited B, right? Sequence F. We already visited B. So we add the Q font in E. We added E in it. So visit neighbor of A. So now we want to F already is discovered, right? F we already visited the F, right? Previously we visit F, right? So from now I finish it. Like I finished the content. Like I want to come back again. So I want to click clarity to you. Again, I want come from first. So here we can see we started from the A and we traveled to the B and visited B and we are the neighbors of A is I and B, right? We have neighbors. I discovered neighbors as we have discovered A neighbors have A, I, and B, right? Initially. So I want to visit first B. For the B, I am taking neighbor I. It hasn't F, right? I enter the F. I have removed A again. Then I want to go back to A. I want to find the B. Then I come to the F. For F, I want considering I again. So I want to visit the I. So from the next side, it is a part B. We visited, first we visited B side. Now visiting A side, I side. So when it comes to I want to visit E. Right? I already didn't visit V. So from this side, I am considering the E as I was visited. That I neighbor has E and F, right? So I visited E, I entered it, I removed F, and I have already existed in F. I already visited, right? It already existed in the FIFO. So from that, I want to consider to move forward like for G. So from the line, I was removing the F because I have already visited it. I marked it as visited. So I'm moving next node to the G. It has a cycle because F has we can see F has three nodes, like sorry, four nodes. What are the A, I, E, B, G? Because I already have visited, I removed for FIFO, I already visited, and E already visited, and B also we come from B because B also visited. Now the part is I want to move for G, right? So I move to the G, and now I visited G. So for now I have G has two nodes like C and H. So from the considering now visit neighbor of E, like we have neighbor here also we have neighbors G. So not only one way we can see the back way we also neighbors like we have F like so E is finished from it here. So now completely comes to DQ next vertex, right? From now we want to DQ the next vertex. So here we consider both because we consider two neighbors here. So visiting neighbors of G like C, G, F, H. So we want to move to A because already we come from the F, right? So it considered C as a nearest. So visit the G neighbor. So then we have other neighbor as H. So it visit again H. From now it entering the Q as it entered the Q in CH. So I want to take H is discovered. Now G is finished, right? I remove from the G because I am running from I am visited the place of G and come from the next node, right? So from that I remove G from FIFO Q, right? So again that I want to visiting C and H, right? From this C node had G, D, H, right? Already I visited G, right? D is discovered because C is finished. Now we comes to the D, right? I comes to D. I remaining my had H, D, right? Each and every state where we are visiting, it get removed. Okay, when you are visited a node, after it routes, after you want to move to the nearest node, right, from the existing node. So at the time of reaching, we want to eliminate, we want to remove the a already existed node. Now get next vectors. Visit we have D and C already visited, so we comes to H again. So H has only C and G. We removed E here, H here. Sorry. Now we have only element D. So in the graph, so I want to visit neighbor of H and I finished H also. So I have only due to next verticals, there is no vertical. I move from D again. I visit neighbor D. So from here, I in FIFA, I visit, I completed A, B, C, D, E, F, G almost. I have only remaining D and I want to stay existed here. Existed now. Currently, I'm existed at D, right? So, what is the nearest neighbors of D? I have C, right? Because C is already finished. Because C, I already finished it, right? So there is no vertex to move forward. I already completed. I have covered all the vertex of the bit search without forming any loop. Like we completed the. Now we want to stop the bit search because we already read it. So once I go back again, then you can find easily there is no. We didn't form any loop because we're using spanning technique, right? Because in D and H, we didn't form any. We can check here. We did not form any loop in between the nodes. Step by step, we covered all the. Step by step, we covering all the nodes in the graph, right? So see how it's we come to again the starting point. So this is the part where we consider a bit first. So we start from the starting stage of A. We completed at the ending stage as D. We stopped at D. We move from we have the neighbors A and B. From A and B we choose sorry. In A we have B and I. We choose B, and after that B we has F, and we can come back to A again. We take AI in FIFO, and we come back to A. I2 we have nodes to E. I go to E, and there I completed the target of F, right? And I to E, E to F. I has three. From the I visited A here, I here, E here, B here. So I exist that comes from the FIFO. Now I'm current state is F. For F node I have G, right? FG is existed now in Q. Again, I travel to the G. Then I removed F because I already visited the F. Again, I G. Again, in FIFO, I want to add C, H, right? My next neighbors are for G, C, and H. I added C and H, and I existed for C. I move to the C nearest neighbor. Then I remove G from the Q, right? So then I have C. Then now I have C neighbors has D and H. From D and H, I want to move to the next neighbor, right? So I reach it to D and doesn't have any neighbors. I come back again. I have H doesn't have any neighbors, so I remove C from it and H from it. So my final neighbor is at H, right? So H has again returned back to C. So there is no neighbor to D and H. So I want to exit the bridge search from here. Here the problem is completed. Here the some example is completed, right? The graph is ended. So this is like this method like this you can find a breadth first search in every graph. Okay. I hope you guys all of you understand about the example sum explanation. Thank you.